Welcome to ePathsala lecture series on postgraduate courses. We are discussing on the paper of cryptography and network security. Today we are going to discuss about MAC algorithm, message authentication code. The objectives of this particular topic to understand the message authentication code and how it is going to be helping in terms of verifying the message it's sent by the corresponding sender, and we are going to discuss about what are the hashing mechanism and how it is going to be helping in terms of your message authentication code algorithm, and also we are going to discuss about the property which is related with the message authentication code, and finally we are going to discuss about the two techniques HMAC and CMAC function related with message authentication code. What is exactly happening in the case of your cryptography? When a person send a message, how we are going to authenticate the message? So in general we already had a hashing technique. In the hashing technique we ensure the integrity of the message, where we generate a hash code and we verified and check whether the message is modified during the transmission of the data. The message authentication code is very helpful in the terms of not only in protecting the integrity of the message, but also it is helping in validity identity of originator. So how I am going to validate where the message has been originated? As we have seen some scenario in related with Alice and Bob, where Alice want to send a message to Bob. When he send a message, Bob will verify the message with the help of hash function. Now the situation is very clear, where Bob knows the message is not modified because the message also carries the hash value, but Bob cannot know that whether it is the sender is Alice or someone else, because the reason is the hashing technique only helping to verify the message is not modified during the transmission. So what exactly needed is who sent the message, whether Alice sent the message or someone sent the message. So that part is very important in the case of authentication of the message. We are not authenticating the user, just we have to keep in that mind. We are not authenticating the user, but we are authenticating the message. That means the message is originated from the person who is sending the message, and it is not modified during the transmission, as well as nobody replayed the particular message. So that is the point where we can able to understand with the help of message authentication code. So exact idea here is it is going to protect the integrity of the message and also validating the identity of originator. So how to detect the changes by advisory to the message? So normally we know very well, whenever suppose a document is going to be given to a person, anything related with the official documents, we usually have a sign and the seal of a particular person. That is a ancient solution. We will have a seal, stamp pad, we use that seal, and also the signature of the particular person to ensure that whatever the content is given, that is given by the respective sender. So more technique where we have breaking the message part and the authenticator part. So we will take a message, not only the message, along with that it will also send the authenticator part. So here we can make it as a tag. The tag will ensure the authenticator part. That is there in the case of your ancient solution. If it is going to be a computer or an internet, suppose a person want to send a message to another person, and you have to ensure whether the message has been originated from the sender. So how it is done? Digitally, that means authenticator part, we are using a tagging part and message part. How it is going to be done? Digitally. So this will help you to create a tag of T of M That is, based on the message we will create a tag and send the tag securely. We will send it to securely, the particular tag securely to the who are going to receive the particular message. Both the information need to be sent, the tag and also the tag must be sent securely. So this helps in the digital solution. Suppose if we consider a scenario without an authentication, where you can able to see if Alice want to send a message to Bob, both are using the shared key to generate the authentication message. For example, they are using a K. Alice know the secret key, Bob also know the secret key. So now what happens here is, if Alice sending a message M, exactly the path is between Alice and Bob, there is one person who already have the key. It is assumed that they already have the shared key. Suppose he is generating the message, Eve simply changing the message, because here there is no authentication of the message. So if Eve can generate a new message, you can see that M and M dash, where the Eve can pass the message to Bob. Now Bob has no idea whether the message is sent by Alice or Eve. So what the Bob will do is, the Bob think that the message is coming from Alice and it started to believe on the particular message. Now this scenario here we can able to understand there is no authentication. Now we are protecting with MAC. So integrity protection with MAC, message authentication code. So now we can see that shared key K to generate a authentication message code. So when I take a message, earlier case where there is no tag. Now the scenario is different. The key is going to be between Alice and Bob. Key is not given, just they are sending the message, simply they can able to modify. Now they are sharing the key. When Alice send the message, they will choose the key before sending the message, and using the MAC algorithm, Alice will generate a tag, that is the authentication code. The authentication code is append along with the message, and now this is, even if it is going to be sent over the unsecured channel. Suppose Alice want to send a message to Bob, if Eve is eavesdrop the particular message, is just taking the message through the unsecured channel. Now you want to send a new message, as in the earlier case where the message is not sent with any message authentication code, they can able to reproduce the message as M dash. But this case, if is going to be sending M dash, but what is the MAC content? It is not known to the Eve, because we know very well who are having the K, that is the shared key, they alone can able to generate the MAC code. So now what happens is, even though Eve captured the message, you can forge the MAC where when K is unknown. So now Eve doesn't know the K value, so you cannot reproduce the particular message. So what happens here, even if the Eve sending M dash is not able to generate the MAC. So now our message is protection, that message is ensures the integrity with a MAC. So MAC allows two or more mutually trusted parties to authenticate the message sending between the members. So what happens, not only Alice and Bob, if somebody else, for example, Chris or Doe, they are going to be sharing the key K, they can also securely, or they can also send the message to Bob the Eve does not know the K, then it is very difficult for E to reproduce the particular message. So MAC allows two or more mutually trusted party to authenticate message sent between the members. So only Alice and me know the K of us send M. So one of us has sent the particular message. If Eve cannot participate in the particular conversation. So now this case we can able to see that Chris, Doe, where they all having the K, they can able to participate in the communication, but it is not possible for the Eve. Integrity with hash, we already discussed that in the previous topic. Here there is no need for sharing the key K between Alice and Bob. So what happens here is Alice send the hash message M, then Eve is capturing forge M dash and E is computing H of M dash, where Bob is going to no shared key, but anyhow they can able to send the modified message. But after recomputing that, it is very difficult to get back the original message, because the reason is M is different from M dash, so the message is not accepted by Bob. That was happened in the case of your integrity. So now we can see that can we simply send the message hash with the message to serve message authentication? No, Eve can change the message and recompute the hash value. So what is the idea here is the hash needs more appropriate procedure to guarantee the integrity. So the Bob, even though the Bob is receiving the message, the Bob cannot guarantee that who has sent the particular message, either Eve or Alice sent the message. So to protect the message, both the message integrity as well as its authenticity, by allowing verifier to detect any changes to the message in the content. So what is the idea here is, along with the hash, they should also have a secret key, who also possess the secret key. So how exactly the authentication is going to be happening for this scenario here is, two persons are participating in the communication, sender and the receiver, where they want to send a message M. They will choose the MAC algorithm, and also they decide what key they are going to use. Now we can able to understand here, using the MAC algorithm they will generate a message authentication code. MAC is the message authentication code. Now this code is attached with the message. You can see that the message is not encrypted, it is just tagged. The message is tagged with the code to verify who has sent the particular message. So now the process is going to be happening on the receiver side. After receiving the message, the receiver has to regenerate the message authentication code. The receiver has to regenerate the message authentication code. For regenerating, they have to use a key which has already shared before sending the message. So that is the K, the MAC algorithm, where the message is going to be, and very important that both are using the same MAC algorithm. Now the message is going to be sent to the MAC algorithm. With the help of the key, a new MAC value is going to be generated, that is your message generated on the receiver side. Now both has to be verified. One is from the sender side, another is from the receiver side, what exactly reproduced, that is recomputed one. Then the decision is going to be made with respect to, if both are same, then it is authentic and integrity is verified, else something went wrong. So now we can able to understand the MAC is exactly of your hashing technique what we have discussed in the previous topics. But the important point here is, in addition to the verifying of integrity of the message, it is also ensuring who has sent the particular message, that is originator, who has sent the particular message. So it is very important, because anybody can forge the message and they can able to steal your information. If suppose if you take a banking transaction, if you are sending a particular, if you are doing some transaction over the online, somebody can make a message like a banker and they can able to capture all your information. In that situation where we can able to go for this MAC. So we can understand, suppose an SMS is generated or some information is coming from bank, we can ensure that whether it is exactly from the bank or somebody else. In that situation it is going to be very, very helpful. So we are ensuring not only the integrity, but also we are ensuring who has sent the particular message. So now we can able to see that a message authentication code is a function of message and a secret key that produces a fixed length value that serves as the authenticator. Again we can able to understand here, it is a fixed length variable message, it is going to be given into the, like your message digest. Here also we are going to generate a fixed length value, but what is the thing here is, the algorithm is going to be generating a message from generated from message plus the secret key. So MAC is equal to C of k comma m. MAC is C of k comma m. So k is the key, m is the message. A small fixed size block of data appending a message as a signature when sent. So this is the process where you can able to happening on the sender side and the destination. So it will check for the MAC on the receiver side and compare where it is originated from the corresponding receiver. So MAC and the encryption, as shown, the MAC produce authentication, but encryption can also provides authentication. How? Encryption can also provide authentication, because we know very well, in the case of your symmetric cryptography, if something is encrypted and sent it to you, then we can ensure that who has sent the message, because we know very well to whom we have shared the key, that person alone able to send the message. So that is what is encryption can also provide authentication. Then why we need to use for MAC? So we know very well MAC provides authentication, yes, but encryption also provides authentication. Then why I need to go for a message authentication code? What is exactly an additional thing with respect to encryption? So MAC, why we have to use here is, sometimes only authentication is needed. Sometimes need authentication to persist longer than the encryption. That is archival use. For example, suppose I am going to store the information for future reference. In that situation, I cannot use the encryption process, because at the time when I share the key, that time alone I can ensure that this is going to be an authenticator. But in the case of MAC, I can able to store the message along with the MAC over a period of time. Even if I want to verify the document which has been stored before 10 years, then the MAC will help me to ensure that it is who has sent the particular message. This is not with the help of your encryption process, because we are not going to maintain the details related with the key which is going to be used in the case of your encryption process. So another thing here is, the MAC is not a digital signature. We already know what is digital signature. So here digital signature, we know the property here, digital signature is who has signed the message. That means the user is going to be authenticated. But in the case of your MAC, the message alone going to be authenticated. So that is why its MAC is not a digital signature. So what is the property of your MAC is MAC is equal to C suffix K of M, where K is the key, M is the message, then C is the algorithm where it is generating the hash code. So we are taking variable length message M and a secret key K, whereas we are able to produce a fixed size authenticator. So it also has many to one function. Potentially many messages can have same MAC, but finding these needs to be very difficult. Very rare cases we will go for this kind of potentially having many messages have the same MAC. So we will see that what is keyed hash function as the MAC. So we already mentioned that hash, and also we are going to using a key, then we can say a keyed hash function as a MAC. So want a MAC based on the hash function. So we can go for keyed hash function. That is because hash functions are generally faster, cryptographic hash code is widely used, widely available. So needing a hash including key along with the message. So but hash has internally no key. So what they are doing, hash does not have any key, so they are going for a hashed key message. So some weakness have been found with the keyed hash function. So there is need to go for hashed MAC algorithm, HMAC. So hash based message authentication code was developed by M-29 and in 1996 is specified as Internet Standard RFC 2104 is updated in RFC 6151. Here it uses cryptographic hash function combined with a secret key. So what are the cryptographic functions we already known is, for example, if I take MD5 algorithm, SHA-1 or RepMed 160, Burlpur, okay, these are some of the list of algorithms which can be used for generating the HMAC. So now we will see how the process is going to be happening in the case of your HMAC. The scheme consists of two stages nested, inner and outer hash. There is one inner hash and the outer hash, inner hash and the outer hash. A K plus is the expanded key paired with zeros on the right to result in the B bits of length. So this is the key, it is going to be padded with the zeros on the right, and the intermediate result of first hash pad is increased to the complex of next hash. So here we have different round keys generated for each hash. So stage 1, K1 is equal to K plus XOR of I pad, this is what used as the K1. K2 O pad, output pad, O pad, stage 2. So the I pad is a string of repeated 0x36, that is the bit pattern of hexa value 36, and the out pad is the string of repeated of 0x53. This is what this. So now the hash is going to be generated, HMAC hash is going to be generated, that is K comma M is equal to H of K plus XOR of O pad or H hash of K plus XOR of I pad append with M. So this is what overall process for generating the HMAC of k comma m. So, now we see that it is going to be taking the k plus and I pad XOR, it is going to be of taking the string, from that it is going to be generating a, okay, it is giving to the hash value and the hash value is going to be generated. Then it is going for the O pad where it is doing an XOR operation, from that it is going to be generating, and already we have a output from the hash MAC of your outer hash, and this is going to be given into the inner hash. Then there is an initialization vector for randomization. Then finally we are going to generate an n bit of hash value that is based on your k comma m. So, this is what the simplified visualization of your hash message. So, you can see that key plus IPad XOR, then I key pad. Similarly, with outer XOR, then it is going to be generating. So, from this it is going to having a SHA-1 first pass and the second pass where it is going to be generating the hash value. So, we can able to see that message and it is going to be appended, and hash sum1 it is going to be sum2, then it is going to be generating the hash value. The another hashing is another MAC algorithm is hashless MAC. So, we are not using the hashing, instead of that we are using cipher based MAC called CMAC. So, it is uses block cipher. It is similar to that of your symmetric key algorithm where we have a DES, AES etc. to generate the MAC. So, based on the same idea as a cipher block chaining, that is CBC, various modes of operation we have discussed, cipher block chaining, where they are going to consider any particular block cipher algorithm, either they can use a DES algorithm or AES algorithm. Then it is using as a cipher block chaining to generate the MAC, message authentication code. So, compresses the result to the size of single block. So, unlike encryption, we have more cipher blocks message authentication code. So, here we are not using any hashing technique. So, earlier HMAC we use the, for example, this case if you take SHA, it is one of your hashing technique, but in this case we are not using any of the hashing technique, we are using the hashless MAC. So, we are using the symmetric key algorithm DES or AES to generate the MAC, and is based on the same idea of the cipher block chaining. The compression results to size of the single block. We have another variant, one keyed parallel MAC and universal hashing MAC algorithms. So, this is what the overview of your CMAC. So, M1, M2, Mn, where it is going for an encryption algorithm, your AES or DES algorithm, where it is finally generating a, I think we already discussed about this, how it is going to be used in the case of your cipher block chaining. So, here some of the advantage of CMAC can use the existing algorithm. Encryption functions have property that resist pre-image and collision attack which is happening in your hashing. Disadvantage is encryption, particularly when it is chained much less slower than the hashing technique. So, we are coming to the conclusion to say that we understood what is the need for a MAC algorithm, and also we understand what is the property of MAC algorithm. We have discussed about the HMAC and CMAC, where what are the advantages and disadvantages with respect to your CMAC. Thank you.